Every single time you look up at the night sky and feel that strange pull, that quiet voice asking, "Is there something out there?" You are doing something that took our species thousands of years to even dare to imagine. And here is the part nobody tells you: the moment humanity first seriously tried to answer that question, the method they used was so absurd, so beautifully insane, that it almost didn't happen at all. We are going to talk about the people who decided to point at the stars and figure out exactly what they were. Not myths. Not gods. Numbers. Distances. Physics. And the story of how they got there is stranger, more desperate, and more human than any science textbook will ever admit. Because here is the thing. For almost all of recorded history, looking up at the night sky was not a scientific act. It was an emotional one. You stood outside, the Milky Way spread above you like a wound in the dark, and you felt something. You just had no idea what it meant. No one did. The universe was a ceiling, and humanity had not yet figured out it had a door. So what changed? What flipped the switch from wonder to understanding? The answer is a series of people, obsessive, often broke, frequently ridiculed, who refuse to stop asking the most dangerous question a human being can ask: what if we're wrong about everything? Let's start with a number. 100 billion. That is roughly how many stars exist in our galaxy alone. Our galaxy, the Milky Way, is just one of an estimated 2 trillion galaxies in the observable universe. 2 trillion. If you counted one galaxy per second, it would take you 63,000 years just to finish counting. And every one of those galaxies contains hundreds of billions of stars. The scale is so extreme it stops feeling real. It starts feeling like a hallucination. But here is what makes this mind-bending: for almost the entirety of human existence, we did not know any of this. Not even close. 1,000 years ago, the most educated minds on Earth believed the stars were embedded in a rotating crystal sphere, maybe a few hundred miles above our heads. The universe was small, tidy, and Earth sat at the center of it all. That was the official position. That was the consensus. And it held for a very, very long time. So what broke it? A Polish cathedral official named Nicholas Copernicus was the first crack in the wall. He spent decades quietly doing math in a small room in northern Poland, and what he found terrified him so much that he refused to publish it for over 30 years. When his work finally appeared in 1543, it proposed something that seemed obviously insane: the Earth moves. The sun sits still. We are not the center. We are just one planet among others, circling a star, drifting through a space that is far larger than anyone had imagined. He only saw the published copy of his book on the day he died. Now think about that for a second. A man spends 30 years working out something that will eventually rewrite every science textbook on the planet, and he is so afraid of what it means that he holds it back until there is nothing left to lose. That is not cowardice. That is the weight of a paradigm-shattering idea pressing down on a single human skull. He knew what he had. He knew what it would cost. And it cost the next person even more. Giordano Bruno was not a careful man. Where Copernicus quietly shuffled the planets, Bruno went further, much further. In the 1580s, he stood up and said something that no one had said before, not in public, not seriously: the stars are not a ceiling. They are suns. Distant suns. And some of them probably have planets. And some of those planets probably have life. The universe is infinite. There is no center. There never was. He said this everywhere. In lectures, in pamphlets, in arguments with anyone who would engage him across England, France, Germany, and Italy. He was brilliant, restless, and completely unable to stop talking. In 1600, the Roman Inquisition burned him alive in a public square in Rome. Now here is where it gets philosophically uncomfortable, and this is the part that is worth sitting with. Bruno was not executed for being wrong. He was executed for being right in a way that threatened the entire architecture of meaning that civilization had built. Because if the universe is infinite, if there are other suns, other worlds, other possible lives spinning out there in the dark, then the story of Earth, and of humanity, becomes something fundamentally different. Smaller in one sense. Vastly more interesting in another. But the idea did not die with him. Ideas never do. 9 years after Bruno's execution, a man in Padua pointed a small glass tube at the sky and changed the night forever. Galileo Galilei did not invent the telescope. That credit goes to Dutch lensmakers who were experimenting with glass around 1608. But Galileo did something no one else had yet thought to do: he pointed the thing upward. At Jupiter. At the Moon. At Venus. At the band of light across the sky we call the Milky Way. What he saw shattered him. The moon was not a perfect celestial sphere. It had mountains. Craters. Shadows. It looked like a place. Jupiter had 4 moons circling it, moons that he watched move, night after night, in patterns that only made sense if they were orbiting Jupiter, not Earth. The Milky Way, that blurry stripe across the sky that everyone assumed was some kind of cosmic dust or divine breath, turned out to be stars. Millions of stars. So dense and so far away they blurred together into a smear. In a matter of weeks, Galileo had transformed the universe from a decorative backdrop into a place full of worlds. He published everything he saw in a small book called Sidereus Nuncius, The Starry Messenger, in 1610. It sold out almost immediately. People across Europe read it and felt the ground shift under them. But here is what most people never learn about Galileo. He did not arrive at his conclusions through elegant theory alone. He arrived through obsessive, meticulous, nightly observation. He sat in the dark, cold, squinting, adjusting, measuring, night after night after night. He was not just curious. He was compelled. There was something almost feverish about it. The universe was offering him data, and he could not stop collecting it. And that compulsion, that specific flavor of obsessive curiosity, is something you will find in every person who has ever pushed the boundary of what we know about space. It is not just intelligence. It is hunger. And it does something specific to a person. It makes them willing to be wrong. Willing to be humiliated. Willing to keep looking even when looking costs them everything. Galileo, for his part, was eventually forced by the Inquisition to publicly recant his finding that the Earth moves around the Sun. He was 70 years old and nearly blind. He spent the remaining years of his life under house arrest. Legend says that after his forced recantation, he muttered under his breath, "And yet it moves." He probably didn't actually say that. Historians think it's apocryphal. But the fact that we invented that line, that we needed him to have said it, that tells you something about how desperate we are to believe that truth survives even when it's crushed. That the universe keeps its secrets only so long. Now the question that should be nagging at you right now is this: these men looked at the sky and collected evidence. But understanding what that evidence meant, calculating the true size and structure of the universe, required something else. It required a completely new kind of mathematics. And the person who built that mathematics did it while hiding from the plague. In 1665, a 23-year-old Cambridge student named Isaac Newton retreated to his mother's farm in Woolsthorpe when bubonic plague shut down the university. He stayed for 18 months. And during those 18 months, in near total isolation, he essentially invented calculus, developed his theory of optics, and worked out the laws of gravity. In a year and a half. Alone in a farmhouse. The gravity work is the one that concerns us here. Because what Newton realized, through mathematics that had never existed before, was that the same force pulling an apple toward the ground was also pulling the moon toward the earth. The same force. Acting across space. The universe, it turned out, ran on laws. Consistent, mathematical, provable laws that applied everywhere, not just here, not just in Christian Europe, not just on Earth, but in every direction, at every distance, across every empty void between every star. For the first time in human history, it was theoretically possible to describe not just what the universe looked like, but how it worked. And that opened a door that has never closed. Within a century of Newton's laws, astronomers were using them to calculate the existence of planets they couldn't yet see. Leverrier, in 1846, used mathematical anomalies in Uranus's orbit to predict exactly where a new, undiscovered planet should be. He sent the coordinates to a Berlin observatory. They pointed their telescope at the indicated spot. Neptune was there. Exactly where the math said it would be. A planet discovered by pure calculation before a single human eye had ever found it in the dark. Stop for a moment and feel what that means. Someone used equations, marks on paper, to reach out across 4.5 billion kilometers of space and point to something invisible. And it was there. The universe confirmed its own rulebook. But knowing how gravity works and actually measuring the scale of the universe are two different things. And the scale problem, figuring out how far away the stars actually are, was one of the most stubborn, maddening puzzles in all of science. It took an entirely unexpected tool to solve it. In the early 20th century, a woman at Harvard Observatory was doing work that most of her colleagues dismissed as clerical labor. Her name was Henrietta Swan Leavitt. Her job was to catalog stars, to look at photographic plates of the sky and record their brightness. It was painstaking, repetitive, barely paid work. Women at Harvard Observatory were referred to as computers. They were not expected to theorize. They were expected to measure and record. Henrietta Leavitt measured and recorded. And then she noticed something that no one else had caught. Certain types of variable stars, stars whose brightness pulsed rhythmically, brightening and dimming on a regular cycle, had a precise, consistent relationship between their pulse rate and their true luminosity. A star that pulsed slowly was genuinely brighter than one that pulsed quickly. Always. Without exception. This seems technical. Here is why it detonated everything. If you know how bright a star truly is, and you measure how bright it appears from Earth, the difference between those two numbers tells you exactly how far away it is. Leavitt had accidentally created a cosmic ruler. A way to measure distances across the universe that had been completely impossible before. Edwin Hubble used her discovery, her catalog, her law, to prove in 1924 that the fuzzy smear of light we call the Andromeda Galaxy was not a cloud of gas inside our own Milky Way. It was a separate galaxy. 2.5 million light-years away. And the universe was not one galaxy. It was full of them. Millions. Then billions. Leavitt died in 1921. She never saw what her discovery unleashed. And this is the pattern that keeps appearing, keeps reasserting itself, every time you trace the history of how humanity figured out the cosmos. It is never a straight line. It is always a relay. Someone does meticulous, undervalued work. Someone else takes that work and applies it somewhere unexpected. Someone else gets the credit. And slowly, over decades and centuries, the picture assembles itself. But here is the part of this story that most people do not reach, and this is where the stakes change completely. In 1929, Hubble made another observation. He noticed that the light from distant galaxies was shifted toward the red end of the spectrum, what astronomers call redshift. And the farther away a galaxy was, the more redshifted it appeared. This could only mean one thing: the galaxies were moving away from us. All of them. In every direction. The universe was not static. It was expanding. And if it was expanding, then run the math backwards. Rewind the tape. If everything is moving apart now, then everything was once closer. Then closer still. Then, and here is the thought that should stop you cold, everything that exists was once compressed into a single point. A singularity. Smaller than an atom. And approximately 13.8 billion years ago, that point exploded into everything. Every star. Every galaxy. Every particle of everything that has ever existed, including the atoms that make up your body right now. You are made of material that was once compressed into something smaller than the period at the end of this sentence. This is not poetry. This is the current scientific consensus, derived from over a century of observation, measurement, mathematics, and experiment, built piece by people who stayed up too late, who refused to stop asking, who sometimes burned for their questions and sometimes died before they saw the answers. And there is still so much we do not know. We know that approximately 27% of the universe is made of something called dark matter. We can see its gravitational effects, it bends light, it holds galaxies together, but we have never directly detected it. We do not know what it is. Another 68% is dark energy, a force that is causing the expansion of the universe to accelerate, pushing everything apart faster and faster. We have no idea what dark energy actually is either. Which means the ordinary matter, the stars, the planets, the galaxies, the dust, every single thing we have ever seen or measured or touched, makes up about 5% of the universe. Everything we know about is 5% of what is there. Let that land for a moment. 95% of the universe is something we have never seen, cannot explain, and have no working theory for. The greatest minds alive right now, armed with instruments more precise than anything in human history, are staring into that 95% and, in the most honest scientific terms available, shrugging. And yet, and this is the thing, we are not lost. We are not back where we started, staring at a crystal sphere wondering what the lights are. We know the universe had a beginning. We know it has a geometry. We know it runs on consistent laws that we can describe mathematically. We know other stars have planets. We know water exists elsewhere in our solar system. We know the chemistry of life appears in interstellar clouds. We are not wandering. We are standing at the edge of a vast room, and we can see the walls have doors we have not opened yet. Somewhere right now, a telescope the size of a city block is gathering light that left its source before Earth existed. Somewhere, a mathematician is rewriting equations about the first few milliseconds after the Big Bang. Somewhere, an astronomer is staring at a radio signal that follows a pattern too regular to be accidental and is very carefully not saying out loud what she is wondering. And all of it traces back to that original moment. A person looked up, felt that pull, and refused to look away. Here is the final thing I want to leave you with, because I think it changes how you feel about every clear night you have ever stood under. The light reaching your eyes right now from the Andromeda Galaxy, the faint smear you can just barely see if you're in a dark place and your eyes have adjusted, left its source 2.5 million years ago. Before our species existed. That light traveled for 2.5 million years, crossed the entire gap between two galaxies, threaded through our atmosphere, and landed on your retina. You received it. You participated in that exchange. And for a moment, the universe was not abstract. It was you, and a photon that had been traveling since before humans walked upright, finally arriving at a destination it had no idea it was heading toward. Every time you look up and feel that pull, you are standing in an unbroken line of people who looked up and felt exactly the same thing. And because some of them refused to stop asking questions, because some of them stayed up obsessively measuring, calculating, suffering, recanting, burning, isolating, cataloging, you do not just feel the awe. You understand, at least a little, what you are actually looking at. And if you want to go further down this road, because there is so much more to explore, the next place to go is the question that these discoveries have left almost deliberately unanswered: are we alone? That question, and the genuinely unsettling body of scientific evidence around it, is something worth a deep dive of its own.